All right, so let's do review for test one. I'm going to say this is equivalent to the multiple choice part of the test. So if we look at our assignments, I don't see a test one review unless I click on more down in the lower right-hand corner and scroll all the way down. It says review test one. And that's what I'm going to look at. All right. So you guys are able to see this on your screen?
Yes, sir.
Okay, good. All right, so I'm going to show all the work, even though I think this might be multiple choice and show you work, a little bit of both. It says find the equation for the line that passes through this point and has the indicated slope. Okay, so I have a point and I have a slope, so I'm going to use the point slope formula. I hope you have all these. You're allowed 1 page of notes, by the way, on the test. 1 page of notes front and back, and those 3 formula sheets I gave you, the trig, the calculus, and your unit circle. So you're allowed those 3 and 1 page of notes front and back, anything you want to write on it. Point slope formula is x, it's y minus y1 equals the slope times x minus x1. And since this is the point, I'm going to say this is the x of the first point and this is y of the first point. If I call this the first point, it's the only point. So y minus y1 is 2. The slope is 2/5. X minus x1 is 0. So I'm left with y minus 2 equals 2/3 x. 2/3 times 0 is still 0. I then take the 2 over to the other side. And y equals 2/3 x plus 2. And this is the answer in slope intercept form. However, the answer may ask for standard form. There's different forms. Standard form, general form. Oh, good. Let me write a couple of these down. You guys need to know, this is algebra. Once again, this is all algebra and you have to know algebra. We said that already. So standard form looks like this for a line. Standard form for a line is ax plus by equals c. And then general form is ax plus by plus c equals 0. So standard form is the x and y on one side, the number on the other. General form is x and y and the number, everything on one side, and equals 0. In both of these, the coefficient in front of x must be positive, and the coefficient in front of x must be, no fractions are allowed. No fractions. So can somebody type in, ooh, this is a tough one, the standard form for this? I mean, you may get this answer, but are you able to change that to standard form? What does standard form for that look like? Anybody want to type it into the chat box? How do you change that to standard form? Anybody, anybody, anybody? I think if I wait for you guys, I'll be here all day. It's Monday. You should be awake, ready to go. Okay, so I'll do standard form. Nobody wanted to type it in. I think you guys are all asleep, which is really bad because my Calculus 2 students were asleep during all the lectures. I'm telling you, only only 30% of them passed the test. John, you're close. Well, no, John, you're not close, but you try to put it in general form. Do you see while all the numbers are on one side? Also, John, look at this. I say A must be positive. The number in front of X must be positive. So this is how I would put it in standard form. I need to get rid of the fraction. So multiply everything by 3. When I do that, I get 3y equals 6, or those two cancel, equals 2x plus 6. And then I'm going to take the 3y over, and I get 2x minus 3y plus 6 equals 0. But then I have to, standard form is the number has to get to the other side. So I have 2x minus 3y on one side and a negative 6 on the other. I just have to move it to the other side. So somebody had typed in an answer. Let's see if they got it right. No fractions allowed, Shakira. Look, I even wrote it, no fractions. You can't have any fractions in standard or general form. Fractions are not allowed in the final answer, and the number in front of X must be positive. We don't care about the number in front of Y. That can be negative. But the number in front of X must be positive. So this number is positive. We don't care about these two. And X and Y must be on one side. That's general form. Standard form, if this was in standard form, it would look exactly the same, except the 6 would be taken over to the side with it. Okay, so this is standard form, and this is general form. All right, just another quick algebra review. Moving on to the next question. I'm not going to graph these, by the way. Everything's multiple choice on this test. Give me a second here. Where are we at? Question number 2. Give me 1 second. All right, next question. Consider the points below. Write the equation for a line that's given through these points and parallel to the given line. So there's 2 parts of this. I'm just going to do the first part. I'll leave it up to you to do the second part. So in other words, there's a point, -4, 4. And we have to write the equation, y equals mx plus b. We have to write the equation for that. And it says it's parallel to this line, y equals -4. So these two are parallel. So it's kind of important to understand what you're talking about here. We have a point, and they want us to write an equation for that point when it's parallel to y equals -4. Well, y equals -4, if you look at that, this, when it says parallel to this is not a point, this is the line. Y equals -4. In other words, if I did a t-table, y always equals -4. X can equal anything since it doesn't have any restrictions for X. 0, -4, it's right here. 1, -4 here. 2, -4 here. Do you see? Y equals -4 is a horizontal line that goes through y -4. So can somebody tell me the slope of this line? What's the slope of that line, y equals -4? Everybody should be able to spit it out right now. What's the slope of that line? And I see a couple people typed it in. Except I can't get to it. I don't know what's going on. I have to move it down a little. See, I have this right tablet here and it messes things up. Yes, it's 0. Horizontal lines have a slope of 0. You're right. Don't forget, vertical lines, I think, have a slope of undefined. So horizontal lines have a slope of 0. So the slope is 0 of this line. And since they're parallel, since these two sides are parallel, the slope of this line is 0 also. Parallel lines have the same slope. So they both are 0. And this this line, by the way, look at it, -4, 4, x -4, y, I'm going to put it in a different color, x -4, y is 4. That's this point right here, -4, 4. You see, here's the point, and it's parallel since it's parallel to this line. So we need to write the equation for the red line. Do you see? We have the point and we know these two slopes are parallel to each other. We have to write the equation. Well, I can write it right now. All horizontal lines start with y equals. Y equals 4 is the answer. We're done. The answer is done. But I mean, if you didn't want to do it like that, you could have did point slope form. Y minus y1 equals m times x minus x1. Y1 is 4. The slope was 0. X was a -4. 0 times anything is 0. Y minus 4 equals 0. Take the 4 to the other side. Y equals 4. We already said that was the equation for the line. But I mean, if you see how I did it visually, if this was the first line we're talking about, and we have a point -4, 4, and we know the line we're trying to calculate is parallel to that one, just draw it. All parallel lines start with y equals. All horizontal lines start with y equals, sorry. Okay, give me 1 second here. I gotta handle something. Okay, question 3. We have two functions, f and g. And it doesn't matter what the two functions are. Let's do A. And then let's do E. So A starts off, remember these are composites. A starts off with g of 0. So you always do the right function first, the one that's inside the other. G is 0. Here's g. And we're just plugging 0 into the x. 2 times 0 plus 5 equals 5. So g of 0 equals 5. So this g of 0 changes to 5. The f is on the outside, and the g of 0 changes to 5. Now we just need to know what f of 5 equals. And here's the function f, 4x3, and we're plugging 5 into it. 4 times 5 to the third, 5 to the third is 125. 4 times 125 is 500. And there's our answer. Now on the next one, and feel free to stop me if you have any questions. On the next one, we're just plugging g of x. G of x is 2x plus 5. We're plugging this 2x plus 5 into the function f. In other words, we're plugging 2x plus 5 in here. Okay, so let's see what we have here. We're plugging 2x plus 5 into 4x3. So the 2x plus 5 goes into the x here. 4 times 2x plus 5 to the third. And don't multiply it out. That's the answer. For this problem, you don't have to FOIL it through a couple of times or whatever. Just leave it as it is like that. That would be the answer. So the difference between A is you're plugging a number in, and B and E, we're just plugging the function with the x values in there. All righty. Find the inverse of this function. So I'm not going to graph it, but I do want you to find the inverse. Here's a function. And if you remember the steps for finding the inverse, step 1 was change the f of x to y. Right? F of x gets changed just to y. Step 2, if you remember inverse, a switch. I don't know if you want to say switch the x and the y together. In other words, the y is now the x and the x is now the y. And then step 3, solve for y. Take the 5 to the other side by adding 5. X plus 5 equals 8y. Divide by 8. X plus 5 over 8 equals y. And there's actually one more step. Change y to inverse f so we know it's an inverse. And that's what the answer would look like. And if you were to graph these two, just to show you, if you were to graph these two, 8x minus 5, the y-intercept is 5, and the slope is 8. 1, 2, 3, 4, 5, 6, 7, 8. Boy, that's a crazy. There, it would look like that. And the x equals y line is here. So if we looked at this, then, I mean, if I change this to x over 8, 1, 8 plus 5 over 8, we would have a graph going right through this point. The y-intercept would be 5, 8, somewhere right here. If I could do it, I think this, and then up 1 over 8. It would kind of look, I think it kind of looked like this. Do you see? Because on the y equals x line, they're mirror images of each other. So that's what the two graphs would look like if you graph them. Everybody okay so far? I feel like I'm just talking to myself. You can go over the domains and ranges of all those lines. Hanging in there. That's all we need for a Monday. Oh, they even gave us the picture here in this solution. Same thing I drew, or similar to it. Okay, so let's find these limits for number 5. If you can plug the number in, then do it. Let's find the limit of as x approaches -2 for f. You just plug the -2 in there, and the answer is 5. Plug -4 in there for g, and you get 16. Let's look at this one. Oh, first find the limit as the function f, the inside function. Find this limit as x approaches -2. Well, we already said as x approaches -2. Well, you can do it again. -2 plus 7 equals 5. So since this now becomes 5, we're looking for now g of 5 for the second part of this. We're not plugging -2 anymore. We only plug -2 on the inside function. So now we plug 5 into g. G is x squared. Plug 5 into it. And the answer is 25. Okay. All righty. Number 6. Number 6 is similar to one of the ones from Show Your Work where you have to plug this in. So I am not going to do this. Well, I might as well do this for you. This is the same. By the way, this problem is the same thing as x plus change of x into the function and take the limit as the change of x approaches 0. I think that's what this is. X plus change of x minus f of x. Remember this problem here that we've had? Well, these are that's what this is. So if you look at this function is, the actual function is x squared minus 5x plus 6. X squared minus 5x plus 6. Do you see x squared minus 5x plus 6? So they cut out all this extra stuff just to see if you can multiply this through. So the way you multiply this through is start here. I'm going to start there. X plus change of x squared. You have to FOIL that. You have to FOIL it. If you don't do that, you're going to get it wrong. And then FOIL, you get x squared. You get x plus, or x times change of x. Here you get x times change of x. And here you get change of x squared. So you get x squared plus 2x change of x. These two add together to 2x change of x plus change of x squared. Then I'm going to distribute the -5, and I get -5x and -5 change of x. And then I have the plus 6 after that. I'm trying to find my pen. Then I have the plus 6 after that. Then I had to distribute this negative sign, -x squared negative negative changes to a plus 5x, and then negative 6. If you look, these two cancel, negative 5x and plus 5x cancel, positive 6 and negative 6 cancel, and we are left with 2x change of x plus change of x squared minus 5 change of x. And then all that's divided by change of x. If we factor out a change of x out of all of this, I feel like I did something wrong here. Minus 5x, minus 5 change of x. It looks okay. Factor out a change of x. I'm messing. I'm out of the top. 2x plus change of x. Is that a minus 5? Yes. 2x plus change of x minus 5. You see, this change of x gets out. One of these change of x gets out. There's still one there. And then this change of x gets factored out, minus 5. Over change of x, those two cancel. And then finally, change of x minus 5. Finally, we can take the limit as change of x equals 0. See, you couldn't take the change of x equal to 0 here because it makes it undefined. So when I change that to 0, my answer is 2x minus 5. 2x minus 5. And sure enough, if you look at the derivative of this function is 2x minus 5. That's what this whole process is. It's the long way of taking the derivative, the actual process of taking the derivative. We started that in algebra, but people didn't realize that we were actually doing calculus. And you will have to be able to do one of those, starting off, you have to be able to do one of these and show your work on the show your work part of the test. I can't stress this enough. And I think I do one in the other video. So, I mean, know how to do it. Be surprised. That's the most missed question on the test usually. All right, let's go to the next. 7, find the vertical asymptotes. Vertical asymptotes are invisible lines your graph cannot cross. To find a vertical asymptote, vertical asymptotes are found when the bottom of the fraction equals 0. When the bottom of the fraction equals 0. So vertical asymptotes are when the bottom of this fraction equals 0. And if I factor this, I get x plus 3 minus 1. You got to be able to factor it correctly. So x plus 3 equals 0, or x minus 1 equals 0. Take the 3 to the other side, take the 1 to the other side. X equals negative 3, and x equals positive 1. These are the two asymptotes. Find the vertical asymptotes. The smaller one is x equals negative 3. The larger one is x equals 1. Asymptotes are always an equation for a line. Vertical lines always start with x equals. So x equals negative 3 and x equals 1. Those are the two asymptotes. By the way, down in the next question, it talks about removable or non-removable. Can anybody tell me are these removable discontinuities or non-removable discontinuities? Removable or non-removable? I'm hoping you guys did this homework already. Anybody know? By the way, they're non-removable. Uh-oh, somebody typed something in after I said it. Non-removable, thank you. Yeah, they are non-removable. These are all things you should know. I want to scare you, but you should have done the homework. And now this week, hopefully the homework's done. Studying doesn't happen until the homework is over. If you're still trying to do homework this week, you're not studying and you're not going to do well on the test. I hate to say that, but I've been teaching this calculus class here at St. Philip's for at least 6 years now, this particular class, and I see it time after time. You have to get the homework done, then you have to go back and be able to do those problems without any help. That's study. Study is not doing homework. Study is doing the homework after it's done. So these are non-removable, and I'm going to talk about that next, especially after this next question also, this next question. I'm going to change this next question after I do it. It's really important that we see this, and I'm actually going to show you on, I think I'm going to show you on my calculator, because maybe the visual will help out. So this is the last question, but I'm going to do this 2 different times differently. Say, find the x values at which f is not continuous. Give me 1 more second. I'm sorry. I just have people coming in and out of my house. All right. Okay, so it says find the x values in which f is not continuous. That's the same way as finding your asymptotes or removable and non-removable. Is this continuity removable or non-removable? Things that are not continuous make could make the now I gotta say could make the denominator undefined. So to find if it's not continuous, just whatever makes the bottom equal to 0. And there's 2 ways of going about this. I'm going to factor it, x plus 3, x minus 3, right? This is the difference of 2 squares. So there are 2, x plus 3 equals 0, x minus 3 equals 0. So either -3 or 3 are where my graph is not continuous. So these are both non-removable. And I'm going to show you. See, I know I needed, oh, I have it here. I have a spot here for it. I want to show you this on the graph. If I can get this thing in here. There we go. Let me put this on my calculator. Give me a second. X divided by x squared minus 9. And need to flip it. There we go. And stop sharing this. All right, so you should be able to see the calculator a little bit bigger now. Remember, wrong thing. There's the graph, x over x squared plus 9. If we look at the graph, we have an asymptote at -3 and +3. That's where we're discontinued. The graph stops at those spots, and you have an invisible asymptote where there's no spot at those graphs. You can also look at the table if it lets us. At -3, it's undefined, and at +3, it's undefined. There's no graph there. That makes the 3 and -3 make the graph undefined. There's a discontinuity of the graph at those places, okay? So I want to show you that, but I'm going to do this problem one more time because this is going to help you on the test. So this will help you on the test. That's why I'm doing this. Okay, so I want to do x plus 3 over x squared minus 9. So I want to do this function. And the discontinuity is the same thing. We factor out the bottom. X plus 3, x minus 3. And we have two spots that are discontinuous, where we have discontinuity at x equals -3 and x equals +3. Okay, so we have two spots that they're discontinuous. Just want everybody to understand. But watch what happens when I put this into my graph. Y equals, I didn't hit Y equals. I'm going to let me put it in first in front of my face. Parentheses, x plus 3, close parentheses. I messed this thing all up. I'll start over. X plus 3, parentheses, divided by x squared minus 9. Okay, so there we go. So there's the graph, or there's the equation. Same one I just had, x plus 3. Now when I hit graph, this continuity is at 3. There's no graph there. Why don't we have it over here? Can somebody tell me why we don't have the asymptote over here? It's the same as the last equation. Why isn't there an asymptote on that side? Anybody know? It's the same equation. I mean, the equation that we had prior to this, was just x over x squared minus 9. So I already said there's two discontinuities. This is prior, there are two discontinuities. And it's really important that you understand this. I think I talked about it in the other videos. Yeah, but what does that +3 do at, wait, let me show you something, Eric. You're right about that +3 at the top, but let me show you something. If I go to my table, look, at +3, there's an error, and at minus, I need to change that, table set 0, 1. At -3, there's an error, and at +3, there's an error. I still have two discontinuities. I still have two discontinuities. But it doesn't, does it show up on my graph? Can anybody explain it? It's a really cool explanation, by the way. Let me show you the graph, okay? And we already said there's a discontinuity at -3 because of the +3 on top. The +3, x +3 equals 0 is same thing as saying x equals a -3. Thank you. Yes, x equals -3 is removable. Let me show you what a removable discontinuity is. This asymptote on this side is non-removable. It's non-removable. Asymptotes are non-removable. So I want to show you what a removable discontinuity is. If I can get my window, I know some people can zoom it in and all that, but I'm going to change my window to zoom in on this spot, x equals -3. I want to zoom in on that spot at -3. I'm going to go to -2 to -4. And I'm going to even make my window, my y-axis smaller, -1 to 1. I'm trying to zoom in on that x equals -3 spot. Oh, wait, I did something wrong. Let's see what I did wrong. Window, -2, -4, that looks fine. Minimum, maximum. Minimum, oh, the minimum is -4 is smaller than -2. There we go. Now I'm zooming in on that spot. Look at it. Look at that spot right there. It's hard to see. It's really hard. It's really hard to see. It's really hard to see. Right there. I'm going to zoom in it some more. Let's zoom in it a little more. -3.2. Wait, clear. -3.2 to -2.8. And I'm going to go -0.5. I'm zooming in on a more 0.5. Let's see what this looks like now. Do you see there's actually a hole there? Hole. Because of the top, x +3, at -3, they cancel out. That x +3 and the x +3 on the bottom cancel out, and it causes a hole. This is what a removable discontinuity looks like. A removable discontinuity is a hole in our graph. And I mean, if I even want to focus on it even more, -3.05 to -2.95. I want to get even closer to it, -0.1 to 0.1. If I get closer to it, I see the hole even better. I think I just messed it all up. I did miss it all. That looked fine. That looked fine. I don't know what I did wrong. It's at -3. It should be okay. I don't know what I did. I messed it up. But anyway, you can zoom in on even more. Maybe my y-axis is too small and I can't see it. Maybe that's what it is. -0.4 and 0.4. I bet that's, yeah, there. See, there's the hole. It's a little bit bigger, not much, but you can zoom in on that hole. Okay. So they're both undefined at that point, but this continuity is an asymptote at x equals 3. It's an asymptote, and the graph goes to it, but it doesn't cross it. We call that non-removable. That's an asymptote. This, since it cancels out with the top, it's still a discontinuity, but we call it removable. And it's a hole in our graph. It's a hole. This one is an asymptote because it doesn't cancel out with anything on top. But since this cancels out, it's a hole in our graph, and it's not an asymptote. It's just a hole that is sitting there. So I want to make sure you guys understand the difference between removable and non-removable. Removable is a hole. Non-removable is an asymptote. You can always spot a hole because it cancels with something on the top of the fraction. So removables or holes always cancel out with something on top. Asymptotes don't.